students, let's do lesson 10, polymers and polymerization reactions. Okay, so we will define, illustrate, and provide examples of monomers, polymers, and we'll talk about polymerization in living systems and in non-living systems. Okay, let's move on. So, polymer chemistry. Remember, poly means many, and mono means one. So monomers then are small repeating units that are used to make polymers. So here's a simple way to look at it. These little Lego blocks would be monomers. This is a polymer made up of 3. This is a polymer made up of 5. Or these monomers strung together make a polymer. Okay, all plastics are an example of synthetic or man-made polymers. And there are 2 types of polymerization reactions that you will be expected to know. One called addition polymerization and another called condensation polymerization. Okay, how do we name polymers? Now, in this course, we go really basic. We don't go into this very deep at all. So that's a nice thing for you students. So the name of a polymer is usually written using a prefix poly, and then the name of the monomer. That's it. Simple, right? So take a look. Sometimes the common name of the monomer is used instead of the IUPAC name. So if you had many ethenes, the IUPAC name is polyethene. The common name for that is polyethylene. But anyway, so it's polyethene or polyethylene. So that's how naming works. Very simple. Okay, so let's look at addition polymerization. This is a reaction in which unsaturated monomers are joined through multiple addition reactions to form a polymer. So remember, just like the addition reactions we looked at before, we were dealing with double or triple bonds, unsaturated, and then we just added things to them. So let's take a look. So there are 3 molecules. You know what their names are. It's ethene. These would be monomers. Now, one of the double bonds must break in order for us to be able to do the addition part of this reaction. So the double bond snaps, and I move my electrons out this way. That makes this visually work so we can see how these add together. Okay, now we just simply link these together, and there you have it. Now I have a polymer made up of a bunch of ethene monomers. It's a little deceiving, right? You look at this now, and if somebody asked you what were the monomers, you might say, oh, they were ethanes, but they weren't. They were ethenes to begin with, right? There's ethenes. The double bond broke. Now we added them together. All right, so watch out for that. That's a polymer, polyethene. Now the IUPAC name would be polyethene. This has a common name, polyethylene. Okay, sometimes you'll see these brackets, and I've seen square brackets as well, around the former ethene. And when you see this, it just means that these are the repeating units. So I got those, and then those 2, and then those 2. There's some polyethylene beads. Saran wrap is a common polyethylene that you would be aware of. Milk jugs are made up of polyethylene, just a little thicker. Okay, another addition polymerization reaction. Let's use propene as a monomer. Now here's what propene looks like on paper if we use this structural diagram. But you know, being a chemistry student, that the bond angles look like this. And so I'm going to just change this a little bit so this is easy to draw on paper and you can see how it links together. Now we know the double bond has to break, and then we got to link these monomers together. It's easiest to draw on paper like this. Watch this. Okay, I bend that one bond down there. I bend the end carbon down so that it's going down. So now I can break my double bond and have my electrons form on either side here. It's the easiest way to draw this. Okay, so here's my propene monomers. Now you know the double bonds break, and now I have my electrons, and now you can see this will link together a lot easier with that carbon on the end that's down instead of in the way here. Anyway, we link them together, and there we go. Now, yes, these are bonded together. This is not a bond here. These are not touching. There's hydrogens there blocking that bond. Okay, so there's polypropene. Good. The IUPAC name is polypropene. The common name is polypropylene. All right, perfect. Polypropylene. So you've seen this nylon rope, polypropylene rope. There you go. In my class, we've got these dividers we use for tests. They're made out of polypropene. Those Rubbermaid containers, polypropene. Okay, let's do condensation polymerization. Now, you've seen condensation a couple of times in some other lessons. This is where monomers are combined through multiple condensation or esterification reactions to form a polymer and some water. Now, each monomer must have two functional groups, usually one at each end. So let's take a look. There is a carboxylic acid, and there's one on this end too. Here's an alcohol, OH, OH at both ends. So these two are identical to these two. Okay. Now, it is a esterification reaction. So the carboxylic acid reacts with the alcohol. So remember, the OH comes off the acid and the H comes off the alcohol like this. All right, those go and form water. Now I've got bonding available right here. So you can see why we call this esterification, because I just made an ester, double bond to an O, single bond to an O. Now look, it happens again. I've still got an alcohol over here and a carboxylic acid on this end. Watch this. So those go and form water. And now I have a bonding site available again. And of course, you can see what's going to happen. I've got my carboxylic acid, so the OH, I've got my alcohol, and it just keeps happening over and over and over again. So now I've got three waters, and I've made this long polymer that'll just keep going that way. Now there's my my brackets to indicate the repeating unit now after these two have linked together. So I have this unit, which is identical to this unit all the way along. And notice I have many esters. There's three of them. So you know what they call this? This is polyester. Hey, all right. So we have natural polymers like wool, silk, rubber, cotton, amber from tree sap, made famous by Jurassic Park, that movie, tortoise shells. So look at these. All of these are esters. You got a silk tie, polymers. You've got a silk tie, you're wearing a naturally formed, naturally made polymer. That tortoise shell, that's a natural polymer. Cotton, natural polymer. Wool. Carbohydrates are made of sugar monomers. So here's glucose. That's a monomer. There's sucrose. Put those two together, that's a monomer. Lactose. Now if we repeat glucose units, then we have what we call starch. All right, that's carbohydrate. Proteins are made of monomers called amino acids. So we take a bunch of amino acids, put them together, we make this large molecule called a protein. There are synthetic polymers. So nylon, hey, look at those nylons, ladies. We have polyester. Any of you have any polyester clothing? Kevlar. I don't know if you've heard of Kevlar before. Kevlar is a very, very tough material. It stops bullets. Bulletproof vests are made out of Kevlar. Plastics. Many of the plastics that we have, or all of the plastics we have, are synthetic polymers. Okay, so just a couple more examples. Here's Here's some propene monomers. We put those together, we make polypropene. That's the stuff in Tic Tac lids. Okay, PVC pipes, polyvinyl chloride. So you got ethene with a chlorine on it. Link those together, you got PVC. Polystyrene, so you've got ethene with benzene on it. That's styrene. Link them all together, polystyrene. Teflon, we've seen this one before, ethene with 4 F's. Link those together, and you got polytetrafluoroethene, or Teflon, non-stick coatings. And you've seen this one, glucose units repeating, starch. Okay, well, that is lesson 10.